Hello, my name is Wendy Feng, and I am here today with Conor, Rickard, and Sevin, and we will be presenting our research on the small-scale variability within high-density arrays of fog collectors. So, why is this research important? This research is important because wind-driven fog can be collected both passively and inexpensively. Fog water can supplement the needs of both a community and individuals. Our research on fog variability has implications for future fog collector installations. This research will interest both cloud physicists, ecologists, and people that would like to install a collector for themselves.
Generally speaking, fog collection works by building a fog collector, which is a piece of mesh that's held off the ground and kept taut, so that when wind passes fog particles through the mesh, it is collected into droplets and drained down into some sort of receptacle below. So in the mid-90s, Robert Schimenauer decided that we needed a more standardized way of approaching this fog collection so that data could be more accurately compared between different sites and different collectors. So he came up with the idea of a standard fog collector. And this consists of a square meter of mesh that is mounted 2 or 3 meters above the ground. And there's a trough located underneath the mesh so that as the particles are collected and drained down, they are routed into some sort of measurement device or tipping bucket so that we can collect the data and find a volume of water that was collected. This is important for actual collection purposes because these general concepts could be applied to a much larger collector that can collect a larger volume of water.
Fernandez lab followed these standards and has installed standard fog collectors, about 100 all around California. And Dr. Fernandez realized that certain fog collectors, although exactly like another, would collect more fog water than a collector only meters apart. And recently, he had an opportunity to install arrays of 8 or 10 fog collectors close to CSUMB in order to study this variability.
So for this study, we looked at the two arrays that Conor referred to that you can see here on the map. In spring of 2018, an array of 10 collectors was installed at the CSUMB library down south. And then 4 kilometers north, there were an array of 8 collectors installed in 2019 at the Fort Ord Natural Reserve. Both of these sites are about 2.5 kilometers from the ocean. Both of them have prevailing wind directions from the northwest, and each site has a nearby weather station by which we can compare wind and rain data to our fog collection data. There is a difference in how these arrays are laid out. The CSUMB array is a bit tighter with about a 15-meter separation between each fog collector, while the Fort Ord Natural Reserve site to the north has about a 100-meter separation between each collector, so it's a little more spaced out. When it comes to small-scale variability, the most important things that we looked at these sites were elevation, wind speed and direction, vegetation, and nearby obstructions such as buildings that may affect wind.
This is the Fort Ord Natural Reserve site, and it has oak woodland and seaside chaparral. This is Reservation Road in Marina. And one would think that these collectors right here would collect more water than these collectors, because this is a 40-meter hill, and this is like the foot of the hill. This is the weather station right here, which is strategically to the east of all the collectors. What we discovered is that there is a wind corridor here, and the wind and fog water comes from the ocean right here and jumps up to collector number 5 more often than it does collect number 6 or 7. So 5, 6, and 7 collect the most water, but 5 collects more, and these collectors don't collect as much. We think that there is another wind corridor from the Salinas River north coming down and affecting these fog collectors, because when the wind changes direction, slightly different things happen in terms of which collector collects the most.
Here we have the CSUMB library site, which has 10 fog collectors. Each of these collectors are currently watering oak tree saplings. There is very little vegetation surrounding and also a lot less elevation changes. We believe that these buildings surrounding might have some effect on wind direction, therefore affecting the collection of water.
Us UROC researchers this summer began organizing all of the Fernandez lab files. Dr. Fernandez has data on fog collectors going back 10 years and all sorts of different data types due to different fog collection data methods. So what we started doing was organizing all this data in Excel and developing a workflow. And this informed how we would work in R, which is a software program that's more powerful than Excel. And this all informed the installation of a new database with standard variable names and standard data files, which we cleaned by hand, but we also wrote code in R that will help us to clean the files quickly. And we also began writing code to analyze the data and aggregate it to compare it to rain data and wind data.
So here we have the CSUMB library graph, and this is from the dates of December 2018 to June 2019. On the left here, we have the volume collected, which is in liters, and on the bottom, it tells you which collector number they are. So we can see here that collector number 1 collects more water than all the rest of these collectors. But upon our research, we have realized we don't have enough information to find out exactly which variables affect this collection, but we would love to do further research on this.
So this is a graph of all the collectors at the Fort Ord Natural Reserve and of the wind data that we had from the weather station. And as you can see, all these events occurred at night and dissipated at 9 a.m. in the morning. This blue line is fog collector number 5, and it is the clear winner. And these are fog collectors 6 and 7. And the rest of the fog collectors are down here, and they collected less fog. Now, there is a correlation between wind speed and fog collection, and this confirms research that we've read where the optimal range for wind speed is 2 to 5 meters per second. But it could also be coincidental because at 9 a.m., when the wind speed picks up, the solar radiation is also high enough to make the fog dissipate.
So we feel that we've made significant progress in understanding fog collection better and especially understanding the small scale variability within these sites. However, there are quite a few improvements that could be made in future research. For one, we would like to have more wind anemometers installed next to each fog collector so that we can get more accurate wind data at a small scale to compare to our small scale fog collection data. Another issue is that we need a more robust data history. These arrays that we were looking at were only installed 1 or 2 years ago, so they don't have the same rich history that some of the other location sites have. And that would be important in achieving an appropriate sample size of data over time so that we can study the patterns and make more accurate comparisons. Another issue that we ran into is that there is a delay between a fog event occurring and the actual collection of the data, because as the fog passes through the mesh, it has to drain down, and sometimes that happens very slowly. It can take up to 20 or 30 minutes before we actually receive the data. So one thing that could alleviate this is an FM 120 fog monitor, which you can see pictured here on the right. And these would be installed in front of and behind the standard fog collectors, and it would give us immediate data on when fog events occur and would allow us to closer study the fog particles themselves. And all of this better understanding of small-scale variability would assist in further environmental research, as well as in real-world application of using fog collection as a supplemental water source.
Thank you for listening to our presentation. We would like to acknowledge the Undergraduate Research Opportunity Center for funding our research this summer, and to Dr. Daniel Fernandez, Joe Miller, and John Detka for their contribution to our research. We would now like to answer any questions you guys might have. Thank you very much.